Hi everyone, this is Raghuram, aptitude trainer. In this video we shall learn about trains. This is the extension of time and distance problems. The previous video is time and distance. The base for trains problem is time and distance. First watch time and distance problems. The link is given in the right side top corner. You can click on it and watch all my parts. 6 parts are there. Why am I making many parts? Because to cover each and every type of problems related to all topics. Trains is also very important topic in any competitive exams. So here also I'll explain each and every type of problems which may be expected in any competitive exams. So watch all my parts of time and distance as well as now this present topic, trains. Now just recall what I have explained in the time and distance. Time and distance basics are very important for train problems. So there I have explained the detailed triangle. This is detailed triangle. I have explained in the time and distance problems. So here I'll just put a division and here multiplication. This is the basic for trains. So the formula, single formula, we have a distance is equals to D is called distance and T is time and S is speed. So D is equals to time into speed. Speed into time or time into speed, whatever we can write it. So D is equals to time into speed. Suppose if I want a time, so what do you get? D by S. Distance by speed. Suppose I want speed. Speed is equals to, so what do you write? Speed is equals to D by T, that is distance by time. Like this we can find anything. So out of the 3 terms, main terms in the time and distance problems as well as in trains, distance, time and speed. Out of all the 3, 2 will be given. If 2 will be given, we can find the other one, the third one. So in this formula, very easy to remember using the detailed triangle. Another basic thing we should learn in time and distance problems in the trains, so is a conversion. Conversion between, that is suppose 1 kilometer per hour. This is the speed. 1 kilometer per hour. Speed can be tell in 2 ways: kilometer per hour or meters per second. I want to convert kilometer per hour to meters per second. Just divide by 5 by 18 into meters per second. Meters per second. Okay, so suppose the speed is in kilometer per hour. To convert it to meters per second, just multiply by 5 by 18. Suppose if we have 1 meter per second and the speed is in meters per second, we have to convert it to kilometer per hour. How do we convert? Just reciprocal of this one, 18 by, multiply by 18 by 5 and we get it in terms of kilometer per hour. This is the basic conversion I have explained in time and distance problems. How we got 5 by 18, that also have explained in time and distance problems. And next, how to remember. Some people get confused whether to in conversion whether to multiply 5 by 18 or 18 by 5. Very easy. Kilometer is a bigger thing and meter is a smaller thing. Okay, so we want to convert a bigger thing to smaller one, so the numerator is a smaller. And another thing, meters, and we have to convert meters to kilometer. Meter is the smaller thing and kilometer is the bigger thing, so we have to convert smaller to bigger. So to increase the value, just multiply by 18 by 5, numerator the bigger number. In the same way, hour is bigger and seconds is smaller, multiply by 5 by 8. So second is a smaller and hour is a bigger one, so multiply by bigger one, so to increase the value. So the basic thing in time and distance problems, we need the detailed triangle, that is D is equal to time into speed or speed into time, and this conversion. So these are the basic things in time and distance problems and we need here in trains. In this time problems, mainly you get 3 types of problems. The first type is a pole, man, tree, car, object. That is, a train crosses a pole and a man or a tree or a car or any object. So whatever, any object. So here in this case, so we need 3 things: distance, time and speed. Time, we can take it anything. So here in this case, distance, we need to find distance. Here distance is nothing but length of the train. Here the length of the pole, man, tree, car or any object, we treat it as 0. The length of all these things, even the car also, we take the distance as, that is length as 0. So train length and car is something like this, but we take the car. Suppose a train is crossing a car, we take car length as 0 only. So we don't take a car length because it is negligibly very small compared to train length. So we take the train length as the distance, and speed is as same as the speed of the train. In second type of problems, a train going into a tunnel or it is crossing a platform. Here in this case, that is a train is like this. A train is like this. This is the length of the train. We take it as L1. Length of the train, I'll take it as L1 as of now. And there is a platform, something like this. Okay. And the length of the platform, we take it as L2. So in the previous first type, we treat the man, pole, tree, car, whatever with the length of these things as 0. But here we have to consider the length of the platform or tunnel. So whatever it may be, tunnel also. Here in this case, here the train is crossing the platform or crossing the tunnel. So here distance is nothing but L1 plus L2. Always we take the three terms, distance, time and speed. Here the distance we take as L1 plus L2. What is L1? Train length plus tunnel length or platform length. Combinedly we take it as a distance. And the time we have to calculate, and the speed. Speed is the speed of the train, because the object here is all the object is not moving. Suppose the object is not moving, the speed we don't consider here. Here also the platform or tunnel is not moving, so we don't consider the speed of the platform or tunnel because it does not move. Here also the pole or man or car, if it is not moving, so we treat it as speed is 0. So speed, always we take it as the speed of the train in the first two types of problems. Speed as the speed of the train, because the object is not moving as well as the platform and tunnel is not moving. In third type of problems, we get a second train or a object. Object can be a man or a car. So we don't take tree or pole because it does not move. The moving object, here we take moving object. The moving object, it can be man or car. Suppose a train is going like this. Another train, this is train 1 and this is train 2. Okay, so train is going in some direction and train 2 is coming in opposite direction or same direction. So here in this case, we have to consider the distance as combinedly L1 plus L2. Here also it can be a man or a car. So if it is a man or car, we don't take the length. So combinedly distance will be the length of the train itself. Here also, even though the object or man, the object is nothing but man or car is moving towards or opposite direction or same direction, whatever it may be, so we treat the length as 0. If it is the second one is a train, we treat it as length. We treat the length. So distance is equals to first train length plus second train length. In the case of second train, suppose the second object is a man or car. Suppose man is coming towards the train or going in the same direction of the train, then we treat the length of the man or car as 0. Here also we take the length of the car or man as 0. So the distance will be only L1, that is the length of the train. And what is the difference here? The speed. Speed is different. Here comes two types of problems. Relative speed, we treat it as relative speed. Opposite direction and same direction. So second train or object is moving opposite direction, it's coming opposite direction or moving in the same direction. We have to consider these two. In any way, opposite direction or same direction, the distance is nothing but length of the first train plus length of the second train. And here comes the speed. Here in this case, opposite direction. If it is opposite direction, we treat it as the speed is equals to s1 plus s2. s1 is the speed of the train, s2 is the speed of another train or object, whatever it may, man or car, if it is coming in the opposite direction. Same direction, suppose if it is in the same direction, it can be a man or car or train is moving in the same direction. Another, suppose one train is moving in the same direction, and parallel track, another train is moving in the same direction with different speeds. So then we treat speed is equals to s1 minus s2, where s1 is bigger. We have to take the bigger speed minus smaller speed. This is the thing we have to remember. Always in any case, opposite direction or same direction, object is moving in the opposite direction or the same direction, we treat distance is equal to L1 plus L2, but the speed is somewhat different. Opposite direction and same direction, it is somewhat different. If it is opposite direction, speed of first train plus speed of second train or second object. Here, if it is the same direction, you have to remember this very important point. If it is in the same direction, speed of first train minus speed of second train, or speed of first train minus speed of other object. That can be man or tree. So these are the three main problems you get in trains, where if you understand this concept, the train problems are very easy. Now I am going to explain some problems which may be expected. So I am explaining each and every type of problems which can be expected in any competitive exams. I'll cover each and every type of problems. In the first type of problems, distance is equals to train length. That is, it is crossing a pole or a man, and the speed is equals to speed of the train. And second type, that is it is crossing a tunnel or a platform. Distance is equals to L1 plus L2. Nothing but first L1 is the train length plus L2 is the length of the platform or tunnel. Here speed is the same, the speed of the train. And third type, some other object that can be a train is coming opposite direction or same direction. Anyway, we take the distance is equals to L1 plus L2 in case of, that is L1 is the first train length, L2 is the second train length. Suppose if it is an object, we take the distance is equals to only L1, train length. We don't consider the length of the object. Remember, this is the second train, and here the object. In the object we take the object distance, length is equal to 0. And when comes to what you call speed, here speed is equals to s1 plus s2 if it is in the opposite direction. Here in this case, s is equals to s1 minus s2, it is in the same direction. s1 is the speed of the train, s2 is the speed of second train or object. Here s is equals to s1 is the speed of one train minus speed of second train or object. So it's in the same direction. You just remember all these things, then the train problems are very easy. Let us see some problems. Let us see first problem. So what is the speed of the train of length 600 meters if it crosses a pole in 40 seconds? Here crossing a pole, that is first type of problems. You just consider which type of problem. First take, if it is train problems, for first type, which type of problem it is. The first type, crossing a pole or man or object. Second one, a tunnel or platform. Third one, two trains, both are moving. Okay, here in this case first type, train length. So distance is equals to, we take the length of the train as the distance. What is given length of the train? 600 meters. So we take the length of the train as distance. And what else is given? Time. The train crosses a pole in 40 seconds. So 40 seconds. So what is given? Distance. Remember, distance is nothing but length of the train. What do we need to find? The speed. So we know the speed, speed formula. Nothing but distance by time. What is the distance here in this case? 600 meters by 40 seconds. Remember, the speed will be in two formats, that is meters per second and kilometer per hour. The distance must be in kilometer. If it is in kilometer, it must be in hours. If the distance is in meters, the time must be in seconds. So here meters, seconds. So we have in the same format, meters per second or kilometer per hour. Both must be in the same format. Now the cancellation, 0 0 cancel, 2 2s and 2 30s, and again 2 1s, 2 15s. So the answer is 15. What's the speed? Meters per second or kilometer per hour? Check here, meters per second. You write like this, meters per second. So the answer is 15 meters per second. Let us see the next problem in trains. What is the time taken by a train of length 450 meters with the speed 54 kilometers per hour? Here in this case, out of this distance, time and speed, the previous problem, what are the given values? Distance, time, and we found speed. Here in this case, what is given? Distance and speed. We need to find time. So what is the time taken by the train of length 450 meters? So here in this case, what is the distance? Nothing but length of the train. What's the length of the train? 450 meters. And the speed is given as 54 kilometers per hour. 54 kilometers per hour. Now we need to find time. We don't find time directly because see here, the distance is in meters but the speed is in kilometer per hour. So we have to reduce it to meters per second because the distance is in meters. So let us convert speed is equals to 54. Now what do we need to convert? Kilometer per hour to meters per second. That is, it is to be reduced. To reduce, what do we multiply? 5 by 18. Remember the conversion. Multiply by 5 by 18 or 18 by 5. Have explained this very easier form. 54 kilometer is to be converted to meters. That is to be reduced. To reduce, multiply by 5. That is the least value. And here in this case, to convert meters to kilometer, multiply by 18 by 5. That is 18. The huge value. And next here in this case, cancellation. 18 3s and 3 5s are 15. So here what is 15? Meters per second. Now the distance is meters and the speed is meters per second. So we can find very easily time. We need to find the time. Distance and speed are given. We need to find time. And what is the time formula? Distance by speed. Distance by speed. And next here in this case, what is the distance? 450 meters divided by the speed is 15. Any cancellation? 3 5s and 15 3s directly we can cancel. 15 3s are 45. So 15 30 is 450. So the answer is 30. What is 30? Is it in seconds or hours? Just take the speed. What is the speed? Meters per second. So the time will be in seconds. So the answer is 30 seconds. Let us see some more problems in next video. If you like this video, please give it with a like and share with others. You can also leave comments and suggestions below. Subscribe to our channel and stay updated more such tutorials and videos. Thank you.